Hello everyone, my name is Krishna Pawar and this is my Innovation Lab project, Sentiment Analysis in Constrained Environment. Firstly, in this video, we will understand why this is important and secondly, how we are doing it. So let's start with our presentation. Importance of rating emotions in conversation. Emotions influence how people communicate. Identifying someone is angry or happy, it provides context for their words. For example, if a if a person is angry, it indicates frustration, not necessarily a personal attack. A happy tone might suggest openness or willingness to engage in a conversation. Emotions help in avoiding miscommunication, as misjudging an angry remark as rude instead of stress related can escalate conflict unnecessarily. Role of emotion in online communication. Why non-verbal when we are in online meeting, mostly we are not able to see the face of the person as the person is presenting, and it is difficult to predict the emotion of the person by seeing his face. Thus, emotion can, and as we know, emotion can play a crucial role because emotion helps in improving communication, build empathy with the person, and enhance the productivity. And thus, here comes our main idea for this project. Our main idea is not just to predict the emotion, but it focusing on predicting emotion in a constrained environment. The idea is that during conversations or meeting, audio can be analyzed in real time to predict the emotion of the speaker. If the speaker is angry or very sad, the impact of the message or the value of their point might be less significant than compared to the person with a happy or neutral tone. If a person is in fear, which indicates that he or she is not in best frame of mind to make a decision. This context is crucial in decision making or prioritizing messages. Our goal is to create a high accurate emotion predicting model that can be deployed on devices with limited resources. And here begins our journey for achieving our goal. The tech stack used in this project is these languages: Python for developing the deep learning model, along with Scikit-learn and PyTorch, HTML, CS, and JavaScript for the web page. Dataset. We have used Toronto Emotional Set dataset for training our model. It consists of over 2,800 files, which contains of which are spoken by two speakers and has seven emotions. These emotions are angry, happy, sad, fear, neutral, disgust, and pleasant surprise. Now coming up on to the various models and why we have taken these models. So firstly, we have taken two LSTM models and a GRU model, then applied a neural architecture search on these on an LSTM model to find the best model, and then at last we have used a Wave2Vec model. Our idea is to you concatenate all of these models to make a very less a very small model which can be operated with a high accuracy in a very least resources, and thus we are doing a lot of research on all of these models to find the best model and then make a very efficient model. So firstly, coming up onto the LSTM models, we have taken two LSTM models, one with 128 unit and one with 126 unit. As you can see over here, this is the architecture of LSTM 256, and this is the architecture of LSTM 126. We are using ReLU as activation function and dropout to prevent the overfitting. Next, we have a GRU model. GRU requires less training time as compared to the LSTM model and has a similar accuracy to the LSTM model. It also requires less computational complexity as compared to the LSTM model. Dense layer for classification with softmax activation function. Lightweight as compared to LSTM with similar accuracy and fast training and inference time. As you can see, the accuracy of the GRU model over here, 96.43%, is similar to the LSTM models, 96.96% and 97.68%. Now, coming upon to the neural architecture search. This is our step to find the best architecture for a LSTM model. Here we have taken two LSTM layers, then a dense layer with few dropout layers, and you can see the best architecture has a test accuracy of 97.50%. Now, since we have seen few large models, what our idea is to build, but our idea is to build a very small model that can be operated in very less resources. So what we'll do, what we'll try to build a small model and train it using these teachers model so that we can get a higher accuracy for a very small model. Hence, we have used knowledge distillation for light-weighted student models. We have built three light-weighted student models, two LSTM models, and a GRU model. And here are the benefits of these. Achieved comparable accuracy compared to teacher model, reduced model size and inference time for deployment on resources and constrained device on resource constrained devices. And here are, as you can see, these accuracies of student model and teacher's model are very much comparable. Although the teacher model has more accuracy because it is trained over the original data set, while the student models are trained using these teacher model. As you can see, the student LSTM model 128 model has an accuracy difference of 0.53%, whereas GRE model has accuracy difference of 0.71%. Now we are using wake to wake fine-tuned model. As you know, the Facebook has developed the wake to wake model, and we are training it on data set to get a very much high accuracy as compared to our previous LSTM and GRU models or even the NAS architecture model. Here are the accuracies of this wave to wake model, and here is the evaluation of this model. Evaluation loss is 0.18, accuracy is 1, precision is 1, recall is 1, and we have run it for 3 epochs. This wave to wake model has outperformed the traditional LSTM and GRU model. So here comes so the main idea of this project was to concatenate all of these LSTM models by finding a best LSTM model using the neutral architecture search so that we can concatenate these the model obtained from the NAS and the features extracted from the wave to wake model so that we can concatenate both of these features to build a model with less number of with less with very small size that can work in resource constrained devices. And here is our web page for checking the model. We have used Python and Flask to handle the backend process, and for frontend we have used the HTML and CSS and JavaScript for seamless interaction. Integrated libraries like PyTorch are also used for efficient model execution. The user can upload the file from here and click on analyze button, and then we'll get the output. I will also show and run the code, the the web page. So this is our web page. Here, as you can see, there is a choose file button over here. We can click on it and choose the file, that audio file from over here. So as you can see, I have few files. Let's analyze this file. So let's analyze. It is processing the audio and here is output. It shows that the significant emotion in this speech is angry with the probability of 0.57 or 57.25%. Hence, was our presentation for the Innovation Lab. Thank you.